I am Joita Bashak, Assistant Professor of Philosophy at Shamshi College. I am going to present the set theory as a part of logic in philosophy. Firstly, I discuss set theory's position in logic. Logic has two parts. One is deductive logic and other is inductive logic. Deductive logic has two parts, that is formal logic and other is philosophical logic, as you can see. The next slide is formal logic has its two parts. One is traditional Aristotelian logistic or logic. Second is modern symbolic logic. This modern symbolic logic has 6 division. One is sentence logic, predicate logic, Boolean algebra, mathematical logic, modal logic, then many valued logic. Mathematical logic has two division. One is set theory and the other is proof theory or mathematics. Now, understanding to understand what is set. Set are the classes. Basically is a simply synonym of class, that is called, it is a definition of W.V. Quine. The three main features of set is, in a set it at least has more than one member. Set basically has two member, minimum two member, maximum many members. Second feature, a set must have a property. Set that is example of men set, which has the property of menness, dog set, etc. Third property is, in set theory we have also an empty set. A set having just one member is not to be considered identical with member. The empty set also has zero member. Empty set called null set also. Therefore, set is a bunch of member which collection of many things, is a collection, is a bunch, that is called set. Set of mangoes, set of men, set of teachers, set of benches. Therefore, set in a set theory, that is three basic concepts. One is set has at least more than one member, it has a property, and we also have empty set or null set. To understand set theory, we need to know the basic concept of set, that is membership, identity, subset, proper subset, interaction, union, and difference. Membership is a concept when A is a member of B, then a man like Ram is a member of men set. That is called a membership. Identical means A is a set, B is a set. A and B are identical if and only if for all x, x belongs to A, if and only if x belongs to B. there then subset. Subset is the concept of K is a set, L is a set, then for all x, x belongs to K. If x belongs to K, then x belongs to L. In that case, we told that K is a subset of L. Proper subset is the relation between K and L also. This for all x, x belongs to K. If x belongs to K and then x belongs to L, and mention that K doesn't equivalent to L. L is a member. L has more than member which K has. Interaction relation is that for all x, x belongs to K. Interaction with L if and only if x belongs to K and x belongs to L. K interaction with L if and only if there is a common member. Then we told that K and L is an interaction relationship. Union for all x, x belongs to K union L if and only if x belongs to K or x belongs to L. Difference for all x, x belongs to K differentiate L if and only if x belongs to K and x does not belongs to L. In that case, we said that K difference L. Now my next slide is about how do we interpret categorical propositions in set theory. There are four categorical propositions, that is A, E, I, O, identical with vowels, English vowels. A proposition is all men are mortal. In set theory, A proposition are explained in that way. There is man and there is immortal. That set is empty. Men and immortal. That set is empty. So we explain with M intersection curl T, mortal is T, mortal is equal to T. M intersection curl T is equal to 0. Therefore, men and they are immortal. That set are null set or empty set. Therefore, all men are mortal. E proposition's explanation is kinds of that. No men are immortal. So, nothing is men and mortal at the same time. Nothing is men and mortal at the same time. Men and they are mortal, that is not happening. Therefore, that is men intersection immortal I is equal to 0. I proposition is some flowers are red. Flowers and they are red. That set has at least one member. We also know that rose is red and rose is also a flower. Rose belongs to flower set and rose belongs to red set. Therefore, some flowers are red. That is, interpretation is F intersection R not equals to 0 because there is a one member, that is rose. Some flowers are not red, that is also has member. Flowers and they are not red, that is also has a member. that is we call flowers, that is we call lotus, national flower. Flower and this is not red. Lotus is pink, white. So these four categorical proposition in set, in that way we interpret the categorical proposition in set. That is the end of my presentation. Thank you.